Hi everyone and welcome back to Maths and Physics with Mr. Simons. Right, today's lesson on energy and change, we're looking at the second variation coming from November 2019 past exam paper. Now we give you equation plus the graph. This time the graph is endothermic. Now I'm glad you are still here and I hope you like and subscribe. And you stay here on my YouTube channel to ensure that you see every variation and that you go in exam fully prepared, right? That's my mission, to make sure you write the best possible exam. So, balance equation for the reaction of carbon with steam is as follows. So we have carbon in solid form plus steam H2O gas from CO2 gas plus H2O gas. Graph below, not drawn to scale, represents the change in potential energy of the substance during the reaction. So there my reactants start at 49, goes all the way to 93 activation energy, and it loses energy till 80 kilojoules per mole to form my reactant CO2 plus H2. Define the term heat of the reaction, delta H. Is this reaction endothermic or exothermic? Give a reason for your answer. Use the information in the graph and write down the value of the activation energy and the heat of the reaction. Right, so let's look at the solutions. So we have the balance equation, define the term heat of reaction. Right, in short, the energy absorbed or released per mole in a chemical reaction. All right, so delta H, how much energy here between the reactants and the products. Is this reaction endothermic or exothermic? In this case, this reaction is endothermic. More energy is taken in than what is released. Right, so more energy is absorbed, you see, from 49 to 93 than what is released from 93 to 18. Right, or in short, delta H should be greater than 0, it will be positive. Right, or as we teachers, my products there is higher than my reactants, therefore endothermic. But just different ways for you to remember it. Right, now there, use the information graph and write down the values of activation energy. So my activation energy is to always start from my reactants to the highest point of my graph. So that is 93 minus 49, gives me 44 kilojoules per mole. I'm showing you the calculations, even though they say we must just write down. So that 44, the 2 marks, comes from 93 minus 49 for my activation energy. Can see delta H is the energy change between my products and my reactants. Right, so use the information to find the heat of the reaction. Delta H equal H products minus H reactants. So my products is 80 minus my reactants, which is 49. So 80 minus 49 gives me 41 kilojoules per mole. Right, so we're still together. Hope you understand. God bless. Bye.